Solid Edge portfolio of products from Siemens brings every aspect of your product development to the next level. Solid Edge continues to improve in the areas of next-generation design with each new release. New for generative design is the ability to apply multiple load cases within the same study so that opposing forces can be used to optimize a design. If we look at this initial study, we see a result similar to previous versions. However, there are some new manufacturing settings that allow control over the distribution of material. The results of this can be seen in the second study, where the material is more evenly spread across the part. Other enhancements allow the creation of an optimized design that could be manufactured using regular subtractive machining rather than having to 3D print. Also, gravity loads or displacement constraints can be added. The part can also be optimized to meet a given factor of safety. The result from the Solid Edge generative process isn't just an idealized shape that needs to be reverse engineered. Siemens Convergent technology allows the use of mesh data downstream. Now Solid Edge will recognize planar and cylindrical faces on the mesh body. Here, a simple sketch on the underside face is used to create a cut to increase the size of the bore. The ability to combine mesh data with regular modeling features are unique to Solid Edge. Back in the assembly, the recognized faces on the optimized part can be used to create assembly relationships, even though it's a mesh body. This gets the part in the right position. One final edit is to add the mounting holes for the part. That is quick and easy and can be done by picking up on the background geometry, all made possible by Siemens Convergent modeling and synchronous technology. Our machine also needs to be able to hold and support different sized bottles. Here we require an insert in this pocket that will do this. The new bottle we're getting this information from was scanned, which means the assembly is made up of mesh geometry. Even so, we can make use of this to help generate the model. We're only interested in the lower part, so we'll focus on that. Any geometry that isn't required can be quickly removed from the model by using the delete mesh command. The hole that this leaves can easily be automatically filled. A new smooth mesh command can also be used to remove any scanning imperfections. Synchronous technology speeds the process of creating the geometry needed for the bottle insert. Then the scan geometry can be used to create the correct shaped pocket for the insert, which will perfectly fit to the bottle. Assigning a material gives the part the correct properties. Now that the part is done, it can be added to the assembly. Once again, even though this is a mesh body, regular assembly relationships can be used to ensure correct positioning just like they can on a regular solid model. Additional geometry can quickly be added to this mesh model for location purposes. Once again, convergent modeling makes this possible. This even allows rounding to be applied to the sharp edges of the mesh model. And synchronous techniques can now be used to move or rotate faces of mesh models, just like you would on a regular CAD model. This design definitely lends itself to additive manufacture. This can be done directly from within Solid Edge, where multicolor printing is now supported using the 3MF format. In this case, though, the 3YourMind service is being used to find an appropriate supplier and order online. Solid Edge allows you to incorporate mesh models into the design workflow seamlessly, and all enabled by Siemens Convergent modeling techniques. This capability, along with synchronous technology, provides a fast and reliable design process that no one else can match. To learn more about Solid Edge, visit solidedge.siemens.com.